The first 4 problems on the Chapter 13 homework all involve some sort of variation on the combined gas law. Number 56, we're just using the combined gas law as a whole. So what's happening here is we're changing 2 of our conditions, right? Oftentimes with gases we care about things like pressure, volume, and temperature. And when we use stuff like Boyle's law or Charles's law or Gay-Lussac's law, we usually keep one condition constant, be it temperature, pressure, or volume, and change another one. If we change more than one condition, so in this problem we're changing both the pressure and the temperature, we need to use the combined gas law. So the combined gas law is written to the left over here in number 56, right? It's P1 V1 over T1 equals P2 V2 over T2. One of the key things to remember when you're working with gases is that your temperature is always going to be in Kelvin. From here, it's a matter of plugging things in. So our initial conditions are that we have a pressure of 0.995 atmospheres, we have a volume of 5 times 10 to the 4th liters, and we have a temperature of 32 degrees Celsius. Now that equates to 305 Kelvin. Okay, on the right side, we have our final conditions. So when this balloon rises into the atmosphere, it'll rise to a height where the air pressure is 0.720 atmospheres, and the temperature is negative 12 degrees Celsius. Negative 12 degrees Celsius is 261 Kelvin. And you get that conversion because you know that Kelvin equals degrees Celsius plus 273. We don't know what our final volume is. That's what we want to solve for. So we're going to leave V2 alone. From here, it's just a matter of doing the math, and if you do so, you should end up with 5.91 times 10 to the 4th liters for your final volume. Problem number 58 involves there being a constant pressure. Okay, whenever you have the constant pressure, it's a Charles's law problem, because what we can do here basically is say that, sorry about that, P1 equals P2. So that means if we look back at our combined gas law, we can cancel out our pressures. That'll leave us with V1 over T1 equals V2 over T2. From here, the important thing to remember, again, is that our temperature is in Kelvin. So, our initial volume is 2.50 liters. Our initial temperature is 22 degrees Celsius, which equates to 295 Kelvin. We don't know what our final volume is, but we're told that our final temperature is 43.0 degrees Celsius, or 316 Kelvin. So we'll fill that in for our temperature too. If we solve for V2, you get volume equals 2.68 liters. Number 59 ends up looking a lot like number 58. However, this time, instead of having a fixed pressure, we've got a fixed volume. And in other words, now we've got V1 equals V2. So again, looking back at our combined gas law, V1 equals V2, they cancel each other out, and we get Gay-Lussac's law. P1 over T1 equals P2 over T2. Once again, we got to make sure our temperatures are in Kelvin. So we convert our 30 degrees Celsius to Kelvin, and on the left side, we've got 288 Kelvin. We've got, first thing we do is we convert our 15 degrees Celsius to Kelvin, because that's our initial conditions. So that's, on our left side, that's our 288 Kelvin. Our final conditions have a temperature of 30 degrees Celsius, so that'll be on our right side. Our T2 then is 303 Kelvin. Our initial pressure is 1.11 atmospheres, that's what we start with, and we want to solve for our final pressure. So we leave P2 blank. Solving for P2 gives us a pressure of 1.17 atmospheres. Number 60 involves similar methodology to number 56, and you use the combined gas law again. So we've got 2 sets of conditions. We've got an initial volume of 500 milliliters. We've got an initial pressure of 108 kilopascals and an initial temperature of 10 degrees Celsius. So we're going to fill in all those pressures and volumes and temperatures on our left side of our combined gas law. We can use milliliters here. We don't need to use liters. As long as we're consistent with the same volume units being on each side of our equation, we can use milliliters, we can use cubic feet, we can use whatever, as long as the units for V1 are the same as the units for V2. On the right side, we're given a new set of conditions. So we've got a volume of 750 milliliters and a temperature of 21 degrees Celsius. We don't know what our final pressure is. That's what we've got to solve for here. Now that we've got everything filled in, again, it's just a matter of doing the math. Doing so will yield a final pressure of 74.8 kilopascals.